right, good afternoon, everyone. I hope you all are having a good day today. So unfortunately, the projector in here, I'm having some issues connecting to it with my laptop. So it won't probably affect you too much if you're watching via Teams. But if you're joining us via face-to-face, I would encourage you to follow along. So make sure your speakers are muted, because you should be able to hear all the audio just fine. But like I say, if at any point, you can't see anything and you're joining via Teams, make sure that you let me know. I certainly appreciate that, because I don't have it on multiple monitors, so I only have the presentation for today. So just kind of right off the bat, I want to talk about what we're going to be discussing for this week. So this week is all about SQL. And you may say, well, we've already covered SQL. And you'd be absolutely correct. We certainly have. So kind of looking through the chapters, I didn't realize there was a lot of repeated content. However, Chapter 10 does bring in a lot of new concepts that are very important to understand when we start talking about more advanced database concepts. So that's really what today's class is about, is covering some of those more advanced technologies. So as such, I've gone ahead and hidden a lot of the slides that are just kind of reviewed. So go ahead and go to the next slide here. So we talk about what SQL is. It's easy to think that it's a programming language, but it's not really a programming language. It's really more of a kind of generic set of standards that people comply to varying degrees. So, a lot of stuff throughout the semester has been, MySQL does it this way. Maybe Microsoft SQL Server does it a slightly different way. Maybe some of Oracle's products do things a little bit differently as well. So just because it is a standard doesn't mean that it's adhered to 100% to a T. So when we talk about this, keep in mind, different companies have different adaptations. It's going to be similar, but it's not going to be the same. So we certainly want to keep that in mind as we kind of go throughout this and kind of discuss what SQL is. It's not one, standard thing. It's really a combination of several iterations of something that's very similar. So when we talk about this, it's all about databases. Of course, we all know that. So there's really a couple key things to know that it provides. And of course, the biggest thing being select. We can do things like create, insert, update. Each of these are very important commands that we can kind of apply to make sure that we can edit our data, make sure we can insert new data. All those are very important things to do. So of course, like I said, it's not a programming language, but we can certainly interface with a lot of different things. Some of the examples on here, things like C#, things like Objective-C, all these can easily interface with the SQL databases that we're going to be using. And that's going to be where we're going to be doing most of the programming. However, toward the end of the lecture, we will talk about some ways we can go ahead and apply some basic programming concepts inside of SQL. So just a kind of quick review on the data types. Of course, we have numeric data types. We have character data types. You'll certainly see this on a test. I won't necessarily ask you what is a binary data, but I may have you do something where you're going to select a reasonable data type for something. If you're making a create statement, for example. Certainly something you may be doing on the exam. So just make sure that you know these. Again, you can certainly look them up. It's open book, open note, open internet as well. So I don't anticipate anyone having any issues remembering what a data type is. Make sure you know them. Of course, when we talk about formatting, formatting in SQL is very important. What happens if you use improper formatting? Most of the time. Doesn't work, does it? So you want to make sure that you follow the format. So if you're using some sort of a number and it has a decimal place, basically you just put that inside of parentheses. So the first letter there, that's the X. That's how long the number can be. So if it's going to be 9 characters long, you have a 9 there. And then the comma D, of course, the D references how many places does the decimal place have. So in this example, most currency, we're going to think about that as being in cents. So if we had, let's say, a currency, what do you think the format would be for that? Just the D. Most of the time, it's going to be expressed in 100ths. So you have 1/100th of a dollar. That's 1 penny. So we would probably have a 2 there, as you see on this example here. And a similar thing with the date. So if you're doing a date inside of SQL, you certainly want to make sure that you put in the appropriate format for it. So you just kind of specify where you want the month, where you want the year, where you want the day. Of course, there's no real sort of guidelines for that on an international level. So it's very important that you understand that whenever you're looking at data to understand what the format is. Different countries have different preferences. I think over in the United States, we're kind of partial to month, day, year, but other places are more partial to things like day, month, year, or year, month, day. So there's lots of different ways to express dates. Make sure that you specify it. Now here's some new information though. So we talk about a collation sequence. This is basically just saying, how are we going to specify the order that something should be expressed in? So we think about this, what is order? Order is simply saying, what comes first, what comes second, and so on. So inside of SQL, this can be very important because we may want to know what something comes before or after something. We may do conditions based on the order, is what I'm trying to say. So in English, we have the letters A through Z. Of course, within that, we also have capital A through Z. We have lowercase a through Z. So we can actually kind of set if we want those to be treated the same, if we want them to be treated differently. We do that with collation sequences. Now, of course, there's other languages outside of English. That's certainly something that I'm sure we're all aware of. And they may have characters other than A through Z. So the book uses the example of Norwegian, which you see here. And basically, what you do inside of a collation sequence is you say, this is the order that I expect them to be in. So typically, if you're doing a database, the default, of course, is going to be Latin 1 anyway. But if you wanted to specify it, it's probably best practice to do so. Where this really becomes important is if you're working with international data. So there may be cases where you have data from several different languages, and you have to figure out, how can I make sure that the order will be logical throughout all of them? It's very possible that the characters may not even be recognized inside of Latin 1. So basically, you would just make sure that you specify whatever will work with your data and make sure that you do it at the top of the file, basically. Something we didn't cover a whole lot throughout the semester was altering a table. This is something where if you wanted to maybe change a column data type, maybe you wanted to add new columns, basically that sort of thing, you could do that using alter. So you could just make sure to do the alter statement. And it's similar to a select. Instead of doing select, you say alter. It's one of the 4 major types. Of course, if you want to take a table out, I think we might have done some examples of this, but basically just drop table. So that's a great way to drop a table that you wanted to update if you didn't have any data that you particularly cared about inside of it. It's a great way to do it. In fact, it's one of the only ways to do it. Just kind of recap on views. So views allow us to do things like have all of our join statements already made. Lots of good stuff with them. Of course, we can make new views. We can kind of remove some of the existing views. We have lots of great things to do there. Similar with indices. So an index will allow us to easily search for things. And when I say easily is not a good word there. I should have said more quickly search for things. So if we have an index inside of a data set, or a database rather, and then we want to search for that index, if we've created an index, it allows us to search much quicker. So basically, we can create an index by just saying create index, and then telling what the index will be comprised of. So really kind of straightforward. Just kind of recap on the 4 major things inside of SQL. These are your 4 major statements. You have your insert statement. What's that used for? Used for inserting new values into a data set. Update, that's used to replace existing values inside of a data set. Delete lets you delete rows inside of a database. And then lastly, we have select. Of course, that lets us return values inside of a database. So those are all very important, and you'll certainly see at least 1 or 2 of those, if not all of them, expressed on an exam. Now, this is where the material gets kind of new. So far up to this point, we've done joins where we've done join, one table on another, and we've expressed it with some sort of identifier equal to another identifier. But that's not the only type of join there is. So when we think about what this is an inner join. We're getting the things that have that in common, and that's all we're comprising of. So if we think about a Venn diagram, and in fact, I can draw on the board today since the So I don't know how well you'll be able to see it, but I'll certainly try to draw on the board. So we have a Venn diagram. Oh, that didn't work too well either. My markers are not the best, but you can see it on here. So, if we look on the PowerPoint slide, we see the inner join we're getting the stuff that they have in common. So we're not getting the stuff that's unique to either. We're only getting what they have in common. And that can be very useful for a lot of cases. But there can certainly be some cases where we want stuff that's they have in total. So if we want to do a full outer join, we're basically getting everything from both tables, including what they have in common. Left and right outer join, we'll see in a little bit. They're very similar. The only difference is the order of the tables that you specify. So if you wanted to do a left, you would do your first table, and you'd say it's going to be a left table, left join rather. Then you put in your right join, and it's going to get everything inside the left table, but it doesn't matter whether or not that specific key that you're using is present inside the right table. Let's see some examples here. So inner join. Again, there's 4 different ways to do it on here. The first way we should be pretty familiar with. That's certainly the way that we've done it throughout up to this point. Let me look at the second table, and because we know that inside of an inner join, the variable is going to be the same, we can just go ahead and say using this variable. So in that case, we put our variable that we're going to be using, or really I should say the attribute we're going to be matching against. We're putting that inside of parentheses. And that allows us to just go ahead and use it. But that only works if the variable is called the same thing inside of both tables that you're matching with. So imagine if I had a case where I called a nation code, nat code inside of one table, and maybe I just call it code inside the nation table. Then we can't do that. We'd have to use the above method. So below that, we have something very similar. We're just not specifying inner join. We're just using it in the default, which is inner join inside of SQL. And then lastly, we're just going ahead and using the primary key. So we're not even specifying which key we're using because we're using the primary key of our first table. In the second table, that's going to be a foreign key inside of it. So that's basically all we're doing there. I think it's best practice to go ahead and specify the table name dot primary key or whatever the attribute is that you're matching against, but you don't have to. You can certainly use some of these other ways as well. Then we talk about left outer joins. So you can see here, we're taking everything from the left table and also the stuff it has in common with the right table. So I see an interesting example here where basically what we're doing is we're selecting everything from T1. That's the important thing. Order is very important inside of the outer joins because we're getting stuff depending on where they are. If we change that one word to right, we're going to get everything from the right table and only get the stuff that the left table has in common with it. So we can see here, we're not including the ID 5 inside of T2. Why are we not including that? Because it's not inside of the left table that we're starting with. So if we had T2 left join T1, then we would certainly have ID 5. If we had T1 right join T2, then we would have ID 5 as well. It really depends upon the order of the tables here, as well as, if you're specifying left or right. So really just kind of think about this graphically. You have something on the left, and you're saying you're going to do a left join. That's the stuff you're going to get. You're going to get everything. So we have ID 1, 2, and 3, just like we do inside of table 1 there. But for the ID 2, you notice that's not present inside of table 2. So what do we have in column 2 for ID 2? It's null because there is no value that exists for ID 2 inside of table 2. So that's really all this is. We see the same thing in right outer join. So basically, again, you're just specifying the order of the tables. This is where this is really important. And you're saying which variable you're using. Of course, you're using because they both have ID. So as you can see here in this right outer join, because we specify the right table being the one that comes second inside of the syntax there, we can see that we have 5, ID 5 inside of table 2, and that is going to be present inside the outer join table. But we don't have a column 1 for the ID 5 because it's not present inside of table 1. So you'll also notice we don't have ID 2 inside this right outer join because it's not present inside of table 2. So that's basically all we're doing with these. It is important to understand these. In terms of memorizing syntax, it's probably a good thing to do, but you don't necessarily have to if you can find it quickly enough. Then full outer join, basically we're just going to do a full join. Now keep in mind this is another case where MySQL does things a little bit differently. We'll get to how we would actually do a full outer join inside of MySQL. But basically what we're doing is we're taking all the IDs from every table and we're just plopping them all in. And you can see there we have a null value for column 2 inside of table 1, and we also have a null value for column for ID 5 inside of column 1 in the table because it's not present inside of those. So in this case, this is what we'll see, is we'll kind of see that take place. So if we want to do this inside of MySQL, we would just do a union between two select statements. So it's pretty straightforward, but we can't just use the syntax for full join. Kind of an odd thing to not include, but that's how we would go about it, just use a union. So here's just some examples real briefly. I won't spend a whole lot of time on these. Basically, this is some cases where you could see the outer joins being used. So if we want to list all of the variables or all items with the details, delivery, quantities, if any deliveries have been made, basically, as you can expect, we're just going to do a left join there. So we're going to first get the item, and then we're going to get the whatever that del is, delivery. So we're just going to do a left join because we want to know we only want the details if the delivery's been made. So that's why we're doing that left join like that. Any questions about these joins so far? Makes sense? All right. So a theta join, this sounds really complicated, but it's not. All we're doing is we're doing a join if some condition is met. So you think about, we have a select statement, we're selecting stuff, and then if we want to do a select statement that has a condition, it's the same sort of thing here. So basically, we have lots of different conditions we can use. We're not limited to using, equals, greater than. Those are just some that we can use. So here's an example here of a theta join. Basically, we're just saying, inside, if we have some list of our employees, we want to see how many people are going to be inside that list before we reach the name Claire. So we're just going to select the count because we're only interested in the number. We're not interested in who those people are. From the employee table A, join B on the employee. So they got the condition there. We want to see where the first name is greater than it is inside the second name. And then we're specifying where the first name is equal to Claire. So basically, we're just seeing all the names that are going to be before Claire. We're seeing how many of those there are. So that's all there is. So like I say, it's really nothing too fancy. That it's basically just a join with a condition. Now, some other new information, though, for this class, correlated subquery. Basically, we've done subqueries before. This is going to be very similar. So what we're doing is we're seeing how we can apply information that we've gathered to a certain join statement. Heck, I think we've even done this exact thing before, but let's just go through it, just to review. So we want to find the stocks where the quantity is greater than the average for that country. So right off the bat, we're going to be selecting the information about the stocks. So we're just going to put that inside of our select statement there. We're going to join the stock on nation because we want to see information about the nation as well. We're going to see what's the average for that country. So I think this was question 10 on the last exam, if I'm not mistaken, something similar to this. And we're basically, if you want to get the average, you want to get the max or the min, you have to do that inside of a separate, subquery. So we're going to see where the stock quantity is greater than, and then we're going to do our second subquery there, or actually first subquery, I guess. We're just going to select the average of the stock quantity from stock. And again, we're just going to join the stock nation code on the nation.nation code. Of course, the reason we're doing that is because we need to know which nation that belongs to. So that's just a brief example there of a subquery that we would use using join statements. Just kind of looking at this visually, this gives us some indication of the results that we may see from doing that. So one thing that must be present inside of a correlated subquery is a clue. And the clue is just basically the condition. So in that last case, we're using the average. We could certainly use a lot of other things. We could use min, max. This is using count as well. There's lots of other things. Basically, any of those aggregated functions that we can use them, and that's going to be our clue. So here's speaking of those aggregate functions, here they are. So of course, count gives you the number of times something occurs. We could do lots of different things with that. We could also, if we wanted to do that by a specific variable, let's say we wanted to get the count of employees by department. We'd put a group by statement on there to make sure that we're going to group the things by the department. If we don't do that, it's just going to give us a sort of one value, and it's going to be the count of the employees for the entire organization. So we've got lots of flexibility there. We can take the sum, of course. We can take average. Lots of different options. So we kind of talk about some additional things inside of SQL. We're not just limited to putting data inside of a database. We can manipulate the data to some degree. Now, of course, there are better ways to do this if we're going to be interfacing with various programming languages. But we do have the ability to do things like run procedure, create procedures, and have a trigger that upon a condition being met, that trigger is going to run the procedure, or it's going to run the function. So this allows us to do things like if we're going to change the price, we're going to go ahead and update the price throughout our database. Things like that. That's what this is all about. Whoops. So basically, we're going to do this using functions. So as you can imagine, we're going to create the function. So just like creating a table, we're going to start off with our good, and then we say function because we're making a function. We're not making a table. We give it a name, and then the real says it's going to return a real value. So then, of course, we say returns real. And in this case, we're taking kilometers, we're converting them to miles. So we take what we have inside of kilometers, and we just multiply it by 0.62. And that's going to give us a rough estimation of the miles that something is. So if we're going to then use this function that we've created, that's a statement on its own. That in and of itself doesn't do anything. So next, to actually use it, we would go ahead and call it. So you'll remember, we just called it the km_2_miles. So then we just go ahead and use the select statement, tell it which variable, or in this case attribute, we're going to use, and say where that attribute is located, and that's going to give us the result there. So any questions about functions or anything we've covered? Again, it's just like creating a table and then referencing stuff inside the table. That's the nice thing about SQL is that the syntax is very similar no matter what you're doing. If you're using a view, it's pretty similar to create a view. Instead of saying create table, you say create view. Same thing with function. Instead of saying create table, you just create function. And then, of course, you tell it what the function will do, and then you're done. This is pretty straightforward, I think. So anyone want to take a stab at this? Write an SQL function to convert Fahrenheit to Celsius. So let's just go through this together. So the first thing we're doing, we're going to write a function. We're going to put our good friend create. And then we're going to create a function. So we say create function. Now we can call this anything we want. I can just call it Fahrenheit converter. And then we're going to put in parentheses, something like for far, because that's going to be our Fahrenheit value, because that's what we're converting from. And then that's a real number, so we just put real. And then just like before, we're going to say returns real. And then lastly, we're going to say return. And now we're going from Fahrenheit to Celsius. What we're doing is we're taking our Fahrenheit value, subtracting off 32, and then that's inside of parentheses. We're doing that first. Then we're dividing that by 1.8. So we just kind of do that inside of parenthetical statements there, put a semicolon at the end, and we're done. So that's really all there is to creating a function. You're just saying what you're going to return and how you're going to calculate that. So there's a lot of different things we can do with that. This can be pretty powerful, but like I say, it's certainly nowhere near as powerful as what you can do with a programming language. So kind of speaking about this, we have different procedures. So a procedure inside of SQL is really something that's going to be kind of used wherever something is changed. A lot of times it's going to be kind of automatically called. We can certainly create manual call statements, but most of the time what we're going to do is we're going to create call statements that upon some condition, or as it's referred to inside of SQL, a trigger is met, it's going to go ahead and run whatever the procedure is. So we have an example here. It's just literally just creating the table, so we're going to skip it. But then here's where the procedure is created. So this is kind of unlike the previous example that we were creating a function, procedures have a little bit more kind of unique syntax going on. So we start off with a delimiter. Then we just go ahead and create the procedure, call it transfer. Now in this case, you can see that what we're going to do is we're going to take all this information in. So we have our different variables we're taking in. We're defining what they are. And then we're saying it's going to be language SQL. That's pretty much a given. And then it's deterministic because this is going to determine actual values. So that's what that deterministic refers to. And then we actually begin what it is. So all we've done up to this point is just basically obtain values for us to use. We haven't actually done anything in terms of telling what we're going to do with those values we've just brought in. So then here's where we actually begin to tell what we're doing with those values. So it's like Java's a good example of this. You know, you have all your different values that you go ahead and you say, this is what they are. So you may say something like int variable name, and that's at the top of your code. It's the same sort of thing here. So just kind of think about it in those terms. We're going to insert into, in this case, the values table. So we're saying what values we're going to insert. So we have the transaction ID, the amount, and the date. Then we're going to update account. So with that information we just insert, we're updating it. Then we're going to set the balance. So we're taking the account balance that was there before. And then we're adding in the amount that the transfer is. So if we're taking in positive $100, we're going to take a previous balance. We're going to add $100 to it. If we're taking away $100, we're going to subtract off $100. So that's basically what we're doing there. And then basically what we're doing is we're just selecting this for not only the account that this is coming from, but also the account this is going to. So that's really all this is doing. It is a fair bit more complicated, and I will be doing one of these from scratch on the test, but it is possible to throw a question on there that asks you to get some information about what some procedure is doing. So again, you won't have to do one from scratch, but do make sure that you understand what's going on here. So basically the main thing is we're getting in our variables at the top. We begin, we say what we're going to do, and then we end by just saying end. So that's really all there is to this. Any questions? All right, so this is how you would kind of view these once you've kind of created them. Basically, inside of MySQL, you should be able to view inside of the schema on the left side. If you use a right-click over there, you should be able to see the stored procedures, and that's how you'd go about making some minor modifications to them if you wanted. It's probably good to see that they're there, because if they're not there, then something's not working. So here's an example of how you would actually go about calling this. So if you wanted to have this inside of your actual code, you could. Basically, you're just going to call the function. So you're literally going to type call. Then you say what the function is. So in this case, it's transfer. In this case, you have the account that this is coming from, which in this case is 101. Just keeping it nice and simple. The account it's going to is 102, and then the amount is going to be $100. So that's what this is doing here. And this is, of course, going to be transaction number 1. That's where that 1 comes in. So that's basically, if we go back, we can see first we have the credit account, then we have the debit account, then we have the amount, and then lastly we have the transaction ID. So that's basically what we're doing there. And then if we wanted to go ahead and not have to manually call these, because it doesn't make sense to manually call these, to be honest. So we use trigger conditions. And of course, in a trigger, we have some set of action, or it could be a single action. If we meet some condition, it's going to go ahead and run whatever we've told it to run. So we can apply a lot of this, and this is where it really gets kind of interesting. Because up to this point, everything we've done in class, we've manually done. When we import values, we manually import the values. When we edit the values, we manually edit the values. Everything we've done has been us telling it directly to do this. With a trigger, we no longer have to manually tell it to do anything. It can automatically do whatever we tell it to, and that can be quite beneficial if we're doing something repetitive. You know, can you imagine if you're a database administrator and you're working for, say, Wells Fargo or Bank of America? Can you imagine having to type a call statement in every time that someone made a transfer? You'd go nuts. You certainly wouldn't be able to do it. So that's why we have these trigger conditions. So basically what we could do, in this case, we're going to show an example where we're going to take some log file and we're going to manually, or we're going to automatically rather, update it. So in this case, we're going to make a table for storing the log rows. That's what this first part is. And the second part, we're going to create a trigger. So just like with the previous example, we're going to start off with a delimiter. And that tells us we're not really doing any queries here. This is something that will be run as we go. So we're creating a trigger here called stock update. And basically this is saying after there's been some update on the stock table, we're going to then go through each of the rows and we're going to insert our log values because we want to store what we previously had, but we also want to have one table where we have everything that we need inside of it, all the current stuff. So basically, we're just taking our old values and we're storing them inside of, in this case, we're calling that a log. So we're just taking those things, and then we're going to go ahead and end the query, and we're good to go. So that's what we're doing there. Then throughout this, we've seen null several times. I just think it's important to note, null does not mean that it is a zero value. Hopefully you understand that. It means that it's missing. For whatever reason, it could be a lot of different reasons that something could be missing. A lot of times if we're running a join statement, it just means that whatever we're joining from or to doesn't have that specific observation. So it's just kind of important to note that there's not really a whole lot we can do about that. Just kind of talk about a couple other things before we head out. Now, it's very important that we maintain who has access to what information. So we've touched on this a little bit earlier, and one of the main ways we discussed doing this is through having views and having certain views that can access certain information. You know, I use the example, you don't want everyone in your organization to be able to see everyone's social security number. That certainly goes against best practices and is illegal. That's certainly not something you'd want to do. So if we're going to have people using the database, not every person in the organization needs to have access to that information. So certainly going to be a lot more easy for certain employees to be able to use a view instead of having, you know, full control over everything inside the database. So that's something we can do, is to create these views, and we can determine which variables, which attributes are going to be present inside that view. Another advantage is we can go ahead, and if we have different join conditions, we can go ahead and specify those inside of the join. So we don't have to manually type them every time. We just create the view once with those inside, and then every time we use it from there, we can reference those attributes from multiple tables. So it's very beneficial from those two perspectives. Then we have the idea of authorization. So someone at some point in the organization has to have full control over the data. That's just a given. Now, hopefully, it's someone you're paying well, and it's someone that you trust. A lot of times, it's going to be your database administrator, whoever that may be. You'd certainly hope you could trust them with all the data because they have it, regardless of whether you can trust them or not. So basically, the whole idea behind authorization, you know, we think back to basic information security concepts. It's what can you access? So, you know, different types of users can access different types of information. So that's basically all this is saying. And then if we want to actually do this inside of SQL, grant, we're going to go ahead and grant certain users certain things. Now, if we have some tool like Active Directory that we're using, we probably already have our employees inside of different groups, depending on what their position is. So we can certainly reference that using this grant tool as well. So I want to make sure that's very clear. But basically what we're doing is we're granting privileges to whoever we are. We say on, you know, object. So the object is going to be whatever database or schema we're referencing. And then to, that's going to be who we're actually giving them to. So it could be a username. It could be a group of users. It could be our entire user base. Basically, it all depends upon how we're actually going to set this up. And then you specify whatever options you want to grant them. So we really have a couple different things here that we can do. We can determine, you know, can someone select information from the database? You know, selecting information can certainly cause a lot of issues. Even worse could be deleting information. You get someone nefarious that could delete every observation you have. And of course, with SQL, it's very easy to make incremental backups so that likely wouldn't cause long-term issues, but certainly short-term issues could certainly cause some issues there. So basically, we can have various privileges that we grant people based upon what we believe they need to do their job. But of course, we have the principle of things like least privilege. We want to give people the bare minimum. We don't want to give things to people that they don't need. If we do that, you know, we have a large organization. We don't know everything about everyone. There can certainly be some cases where an account could be compromised, a person could be compromised. Lots of reasons why we wouldn't want to just grant everyone everything. So then, of course, if we wanted to, we could also, do things like change whether people can update, change whether people can alter, change whether people can create or remove indices. So we have lots of different options there. And as we go throughout this, I think it'll be pretty clear some examples of this. So let's just take a look at these. If we wanted to grant Alice rights to everything inside the stock table, let's say she's someone who works for us. She's the one who maintains the stock table. It makes sense that she would have access to everything inside the stock table. So in this case, we would just do something like grant all privileges on stock. So we're saying we're going to give her full control on the stock table. And then who we're giving it to? We're giving it to Alice. So that's all we'd have to do there. If we want to permit accounting staff to update the price of the stock, it's going to be very similar. We're going to grant update stock price because they can change the stock price on the stock table to, in this case, they're using Todd and Nancy. But imagine we had an Active Directory user group set up. We could just put that in there as well. And that'd probably be a more preferable way to go about this. Because imagine you have an employee who's terminated unexpectedly. In other words, someone gets fired. And if you granted them access manually, that's something else you have to remember to go through and update. Whereas if you're using Active Directory or some similar tool, then you remove them from that or you deactivate their accounts, probably going to be best practice. They can't access your data anymore. That's going to be a preferable way, I think. If you want to grant everybody the privilege to select rows, you just do grant select on item to the public. So public is going to be all your users. Probably be pretty dangerous, but again, it's information about the item. You're not updating anything about the item. All you're doing is just saying which items we have. That's not really sensitive information in most cases. Now, it could be sensitive information if you're a firm that has, maybe some new items that aren't released yet. Then that could be a problem. But I don't know why you'd have that in your item table. So, something to keep that in mind. So we can certainly go ahead and see how we would go about using these grants to reduce. But we don't always want to give people rights. What if we want to take them away? So just like we did before, where we granted privileges, we can just revoke privileges. So basically, we just do the same exact syntax. Instead of saying grant, we're going to revoke whatever privileges we want. So we have lots of great options here, really similar. And that's basically how we go about that. Any questions so far? Again, we just got a couple more slides we're going to cover. Injection attacks are very important to understand from a database perspective because it's very easy to avoid them. So basically what an injection attack is that you have some case where you're inputting a value and you just put a little semicolon there, and then you type in some sort of SQL command. Maybe you want to select star from employee, and then that'll run both whatever you're inputting, as well as getting everything from your employee table. Similar thing could happen if you're going to do something like drop table. You're deleting tables from the database. Basically, if you have somewhere where the user's inputting stuff, you'd probably want to have certain characters, especially the semicolon, not allowed. So basically, you're doing that. You're sanitizing whatever they're inputting, and that's how you would avoid a lot of these injection attacks. So then we also have the idea of avoidance, where basically you're saying we want to see how can we make sure that the input is going to be what we'd expect it to be. And of course, we do that by using data validation. So we have a value, let's say someone's name. Is someone's name going to be 0, 1, 2, 3, 4, 5? It's unlikely. Is someone's name going to be semicolon drop table? That's certainly unlikely. So we want to make sure that we're going to have things within the allowable parameters of whatever we're wanting to have for that specific input. So that's all we're doing there. Just talking about how to avoid the injection attacks. I think this is the last topic for today. Talking about the catalog. So this is basically a fancy way of saying we want to have information about our tables. And inside of SQL, we have a really great way to kind of view all this information in one succinct place. So it's going to be the catalog. Basically, we have our tables themselves, and then we have information about this. We have how many rows they have, how many columns are inside of each table. And basically, we can interact with these the same way we would with regular tables. So if you want to do something like find the table inside a particular schema that has the most rows, here's how we would do it. So we're going to say whatever a schema is called, that's where we're going to get the stuff from. So if we called our schema, let's say, I don't know, test1, then we would just call it test1.tables, just like we do there. So then we would just go through and select things like max table rows. We could also do min, average. We could do a lot of different things here. We're not really limited to any particular thing. So that's basically all we're doing there. So we're just going through. We can do things like table underscore rows, table underscore columns. There's a couple different options for what we would do. That's basically how I would use this, though, is we would just go through and see what's inside the catalog. We could reference. Is it something we're going to do a whole lot? No. In fact, what's another way to see which table has the most rows? Just do select the count of each table. So if you do that, you'll get the amount of rows that are inside the table as well. So this is not something you're going to use very frequently, but it's there should you want to use it. I guess this is the last topic. So natural language processing is something where not everyone's going to be very familiar with SQL. So if you want to run an SQL query and you're not familiar with it, how are you going to go about it? Well, you got two options. Your first option is to find someone who is and have them make your SQL query. I guess you have three options, because your second option will be to learn SQL. And then your third option will be to use natural language processing. So some packages, I don't think MySQL does this, but some of the more commercialized packages allow you to do things like type in a language, just standard, kind of vernacular type deal. You type in something like, in this case, they're using which movies have won best foreign film sorted by year. And then it's going to take that, and it's going to convert that to a SQL query. So that's all this is saying. That's all natural language processing is. So moving forward, SQL, unfortunately, is probably going to become more fragmented. Different packages seem to adopt things in a slightly different way, but that's not necessarily the end of the world, because if you understand what SQL can do, it's all just a matter of searching online to figure out how to do something in that particular syntax. So, if you're trying to do something like, for example, the intersect inside of MySQL, and you're wondering, why is it not recognizing the word intersect? Well, you just Google that, and then it's going to tell you you have to use and exist instead. So those are the sorts of things. You're going to have more differences like that as we continue to add things, but that's not going to be the end of the world, and it'll certainly continue to be, a relevant thing. Like I said, it interfaces with a lot of things. That's what really makes it powerful, is that you can take whatever data you have and you can manipulate it using lots of different tools and techniques. Any questions about today? All right, guys, well, that's all I had today. I hope you all have a great day. I will see you all next class.